Hi, this is Henk Akkermans, and this is Supply Chain Dynamics, Chapter 2, Sysdea Gameplay 7, Information Delay with Noise. Um, we saw in the previous gameplay that with an information delay, when there's a change in the current reported value, it takes some time to find out what the actual value is if that's a structural change. So here it looks a bit silly. Why not make the perception delay really short so that you can immediately see what's happening? Isn't that better? Yeah, in a perfect world that would be better, but we don't live in a perfect world. Our world's a bit noisy. So perhaps it's good to introduce a variable noise. And well, let's say that's indeed there's a standard function called random. And if you do that over between 0 and 1, you see that you get a random value of 1. There are more advanced statistical functions in Sysdea, but I won't go into those right now. If we take the noise factor and put it into the step change, and we say that actually we want a step change of the noise times 5. Don't forget that the average value for noise is 0.5. Then you see more what I mean. What you see is that sometimes, indeed, by accident more or less, we would give this random factor a seed factor, then this would be different. But this particular version, we are very much higher, but then go lower and lower again. And you see that this is a very good reason why we why in a noisy world it's good to have some smoothing out of observations. Over time, this is still a fairly noisy picture. If we would increase the perception delay to a longer period, for instance, then you see that we do still pick up the signal that we want long term towards 9, but it gets less and less noisy. And over a longer time horizon, who cares at the beginning? It's not so clear what is happening. So the length of the delay, the more noise there is, the better you have a long delay. Better it is to have a long delay. The longer the perception delay, the more delayed will be, indeed, the word says it already, will be your your correct perception of what actually changed in the world. So information delay is a very good representation of what humans do and what many systems do in a noisy world. It smoothens out short-term noise factors, and you will find it not so often in our models, but I mean the noise factors, but definitely you will find it in the real